myself Komal Mhaisane. So first of all, thank you Emertxe for offering us the online embedded system internship. It was really helpful for us. We have studied a lot from your team. This project is done with my friends. So Prasad, Rutuja, Krutika and I, we together have contributed equally for this project. So here are we.
So these are the table of contents, what we have learned in whole internship. So the topics learned during the internships, first one is the introduction to embedded C, in which we are studied that arrays and pointers, functional strings, storage classes. Next topic we learned is introduction to embedded system and microcontrollers. Then in that we learn conditional loops and operations. And next we learned the installation of some apps which are required for our project. So the apps are MPLab XIDE, XC8 compiler and PiximLab. Next we learn introduction to peripherals of PIC16F877A, which is the microcontroller we have used in our project. So we attended the multiple quizzes at the end of the week, and the last topic we learned in this internship is Disha workshop. So the introduction to microwave oven. So the microwave oven, or simply microwave, is an electric oven that heats and cooks food by exposing it to electromagnetic radiations. So microwave oven has the 4 modes. First one is microwave micro mode. So this mode is used to cook food in a very traditional manner. And the next mode is grill mode. In grill mode, a microwave grill is a combination over that includes both a standard microwave and a conventional grill with power greater than 1000 watts. Next mode is convection mode. In convection mode, microwaves have an additional heating element and fan to circulate heat throughout the cavity. And then the last mode is start mode. This mode starts the microwave oven. So these are the requirements for our project. First one is MPLab XIDE, which is the environment for our embedded C code. And the next requirement is PiximLab, which works as the simulator for running our code. Next requirement is XC8 compiler, which compiles the project code which is written in the MPLab XIDE. Next requirement is PIC16F877A microcontroller, which we have used in our project. So the next topic is introduction to embedded C. So embedded C is a specialized programming language used for developing software for embedded systems. Embedded systems are computer systems designed to perform specific functions or tasks within a large system, often with constraints or resources like memory, processing power and real-time performance.
Explaining about the difference between microprocessor and microcontroller. Microprocessors can be understood as a heart of computer system, whereas microcontrollers can be understood as a heart of embedded systems. As you can see, a microprocessor is a processor where memory and input-output components need to be connected externally. But if you observe, in microcontroller, it is a controlling device which comprises of memory, I/O output components present internally already. The circuit is complex in microprocessor due to external connection and less complex in microcontroller. Microprocessors cannot be used in compact system, but microcontrollers can be used with a compact system. Now, if you come to the next slide, it is about PiximLab. PiximLab is an open source interactive circuit simulator that allows you to simulate and experiment with electronic circuits. It is an open source software tool which can be used to simulate and test the behavior of microcontroller based systems, primarily those based on microchips PIC microcontrollers. You can use it to design and test various electronic circuits and microcontroller based projects. It provides a virtual environment for developing, testing and debugging firmware code without the actual need for physical hardware. Now, If you come to the next slide, it is about the architecture of PixSim Lab. The microchip we will be using for our project is PIC 16F877A. It comprises of GPIO, graphic processor input output, I2C, RTC, EEPROM, EEPROM, LM35 temperature sensor, ADC, RS232, LEDs, buzzer, digital keypad, SSDs, matrix keypad and CLCD. We will check about matrix keypad CLCD in the further coming slides. Coming to the next, we have CLCD. CLCD stands for Character Liquid Crystal Display. It is a type of display commonly used in electronic devices and embedded systems to provide visual feedback or information. It consists of a grid of alphanumeric characters or symbols that can be displayed in a fixed format. I would like to list down some of the characteristics of character LCD. First is alphanumeric display, that it can display characters like letters, numbers, symbols rather than graphics or images. It has a limited resolution. We have a fixed grid size, typically 16 by 2 or 20 by 4 or similar configurations with a limited number of characters. It is monochrome. Mostly character LCDs are monochromatic, that is they display characters in only one color, often blue or green. It has a low power consumption. CLCDs are mostly known for their low power consumption, so it makes them suitable for battery powered devices. They are commonly used in embedded systems like microcontroller projects, appliances like digital thermometers, clock displays, and here we will be using it in microwave ovens. It provides an interface with microcontrollers or other control circuitry using standard protocols like HD44780. So, character LCDs are straightforward to use and we are still widely employed in various applications where simple text-based display is sufficient. Yes. So, the next slide will be explaining by my colleague as Krutika Khandzode. I request her to share this information.
A matrix keypad. A matrix keypad is a common input device used in embedded system to capture user input in the form of numeric or alphanumeric characters, symbols or commands. It consists of an array of buttons arranged in rows and columns forming a matrix-like structure. Each button corresponds to a unique combination of a row and a column, and by pressing a button, the user can select a specific input. So in this diagram, we can see that there are 4 column lines and 4 row columns. And in between the row and a column, a key is implemented. When no key is pressed on this keypad, the columns and rows are completely isolated. So there is no connection at all. Please note that C1, C2, C3 and C4 are the input to the microcontroller. Microcontroller code reads C1, C2, C3 and C4 to detect the key pressed. And the pins R1, R2, R3, R4 are the outputs to the microcontroller. So columns are the input and rows are the output. The only thing we have to remember here is that when the key is pressed, there will be a contact between a row and a column. So here we can see there is a contact between R1 and C1 and R2 and C2. So likewise, so what are interrupts? So interrupt in an embedded system is a mechanism that allows the microcontroller or processor to pause its current task and temporarily switch to a specific piece of code called as ISR. So what are types of interrupts? There are two types of interrupts, hardware and software. Hardware interrupts are triggered by external hardware events such as button presses, sensor readings, timer overflows, or data arrival on communication ports. Software interrupts are also known as software traps or exception. These are generated by specific instruction in the program. Now, let's see what is ISR. ISR stands for Interrupt Service Routine. So, it is a special function that is executed in response to an interrupt request generated by a hardware event or a software triggered event. Interrupt. ISRs are used to handle time critical tasks and events in embedded system without delaying or disrupting the main program flow. So here is a flowchart of ISR. Here is a ISR. The direction was given. If it is in a forward direction, then we have to call for forward table. And if the direction is given to be in the reverse, then call the reverse table. After calling the reverse table, we have to set the OVD-con value, which is 1. And here, after calling the forward table, let's set the value of OVD-con value. Now we have to return from the interrupt. So this is the flow diagram of the ISR, the working of the ISR. Now let's come to a point of timer. So timer is used to generate delay and counter is used for counting external events. So these are widely used in various applications including controlling peripherals, generating delays and managing real-time operation. The timer is a simpler binary counter which is configured in a circuit or a system as per the need to count the pulses in the system. The value of the timer is automatically set to 0 once it is at its maximum value. So from the oscillator, the clock pulses are given as an input and the counter in the microcontroller is there for the conversion. So let's have a look at the screenshots of our project implementation of the microwave oven. So these are the screenshots we have attached in our PPT. Now we will have a look at the code of a microwave oven.
This is the code. It is written in MPLAB XIDE. Here we have used different macros, declaring it into the main.h and also some functions which are user defined. We have used the predefined functions too. So now let's see the code for it. So we have used if loop and also switch cases for the menu bar. These are the cases. These are the functions which we have declared first and then defined. So here now when we have to save the code, we have to just build it here from production and we can build it. So after this, when we come to the stage here, the loading gets completed. Also we can get to know that build is successful. Now this is all about the project. Now let's go to towards the simulator. So this is the simulator. First let's load the file where we have written the code. So this is the hex file and this is the file, so we have to load it and we can see that it's loaded. Also this contains the reload function. Reload last when we update our code into the MPLAB XIDE, we have to reload the code every time to get the updation into the simulator. This is the PIC simulator. We have used PIC16F877A as a microcontroller. So this is the this is the menu bar, and it has 4 functions: micro mode, grill mode, convection mode, and the start mode. So going towards the micro mode, it is assigned to the 1 number, so we can from this keypad we can click the micro mode. Power is set to as a 900 watts for this, and now we have to set the timer for it. So let's take the timer, and here is the star which assigns it to the clear. We can clear the time if we don't want that time, we can clear it. So let's see, as we click on the star, we have cleared it, and now we can set it again. So let's decide to keep timing as a 13 second, and here is the hash key which is assigned to the enter. This is all done in our code. So just by clicking onto the hash key we are going towards the timer, and hence timer has been started. Now there are three options: start, resume, pause and stop. So this works very well. We can see this has been paused. So here fifth assigns to the pause, and hence we can see that our timer is paused. And now fourth, it resumes it, and sixth, it stops it. So when we get stop, we come to the timer has been reflected, and after that we come back to the menu bar. So second one is the grill mode, which works similar to that of the micro mode. Here is the set time, similar what we have done in our project previously to the micro mode, and hence we have set the timing and we have entered it. Now we can also similarly we can stop it using the sixth number. Now let's go towards the convection mode. So convection mode is the mode where we have to preheat our oven. So there is a particular stipulated time for preheating the oven. So as we click onto the 3, we came to know that we have to set the temperature here for our oven. So this temperature should be less than 180. If it is greater than 180, then we are going to display the time that it is an invalid temperature. So this is all we have done in our project code. Now let's set the temperature as 152 degrees Celsius and enter. As entering it, the preheating has been started. Here we have taken the time required as 18. Usually it is 180, but we have taken it as a 18. So this is what the time remained for the preheating. And once the preheating is done, we can see that it goes towards the set timing. This is the similar to that of the grill mode or the micro mode. Now micro mode has been started, and we have to again set the time, and we can set the time here again and just enter it. So it will be started. Similarly, this is all about the convection mode. Now the oven has been the convection mode. When we started, we set the temperature. The one thing which has remained is this fan. So we can see this fan is continuously working. So this signifies that our oven has been started. Next is the start mode. This starts the oven. So hence we can see here the timer. So for the start mode, usually if it is a 0 seconds, so it basically we have added 30 seconds for it, and just it started for the plus 30 seconds from the 30 seconds. So it basically we have set the timing as a 30 second. That is the predefined time which we have done in our code. So that's it. This is all about our project. Thanks. This was from our side.
Last but not the least, I would like to express my gratitude at the end of this PowerPoint. We are glad to join your internship program at Emertxe Information Technology. The staff was so cooperative and interactive with the students. We enjoyed being in this internship, and we would like to participate in the upcoming internships. As a student, myself, Prasad, Babar, along with Krutika, Khandzode, Rutuja, Shete and Komal, Mhaisane, we would like to express our gratitude to Emertxe Information Technology for letting us join this internship.